Now, one of the things I've been itching to do for a while now, quite a long time in fact, is to be able to do nickel plating. And there's various reasons for that. One, I think it's a really useful process to be able to do in your workshop. But two, for me, it has an actual proper, genuine use. A lot of the model steam engines that I restore and work on are American, like this Whedon Model 70, which I did just recently. And quite a lot of American model steam engines are in fact nickel plated. Boilers are nickel plated, the pipes are nickel plated, pretty much everything is nickel plated. And the problem with it is that whilst it's quite a good plating for protecting metal, it does wear and it can over time basically wear away. And also it's very easy to remove it when cleaning parts if they're badly corroded and there's very little of the nickel left. So on the Model 70 here, the boiler's lovely, the pipe works okay, piston, cylinder, conrod, all fine. The crank is missing its nickel plate, the whistle is, the safety valve, and because this was very badly corroded, so are the blocks that hold the sight glass. So they could all be done with replating. So yeah, so that's what I'm hoping to be able to do. Now there's basically three things that you need to do nickel plating. You need a source of fairly pure nickel, which is generally called the nickel anode. And here we have a 100mm square, 1.5mm thick nickel plate. So that's our nickel. You also need a source of electricity. In this case, we're going to be using a bench power supply. Now I believe the optimum voltage for nickel plating is 4.5 volts. So that's what we'll be getting out of our little power supply. The other thing you need is a nickel plating solution. Now you can buy nickel plating solution. It's commercially made, but it is actually quite expensive. But according to the research I've done, but mainly looking at YouTube videos and that, it's quite easy to make a nickel plating solution. So to make your nickel plating solution, you need a plastic or glass container, a source of electricity, and 2 nickel plates. You also need vinegar and salt. Now, from what I've observed and doing my research, obviously the salt is mixed in with the vinegar and that makes the whole solution more conductive. You can also use a considerably higher voltage to create the solution than is required to actually do the plating. So obviously you can't do the plating without a solution, so the first thing we're going to do is get on and try and make some nickel plating solution. First up, vinegar. And lots of it. There we go. Now we're going to add our salt. And you'll notice I'm using carefully measured quantities in this experiment. And then we're just going to stir this up and try and dissolve the salt into the vinegar. Now I made some hangers for the nickel plates just to make it easier for them to be placed into the solution. There we go. And we'll connect our cables. So it'd probably be easier to do it that way. There we go. Right, now I've also got my handy dandy little digital timer, which we're going to used to time the process. I'll turn that on. Let's put that there for now. There we go. Okay, so let's close in on that a little bit. There we are. Let's turn it on. Now the voltage at the moment is only 5 volts, and I'm going to turn that up because according to the literature that I've read, the solution creation goes much faster if you've got a high voltage. So, well, obviously the current will go up as I increase the voltage. So let's close in on the solution. That's 7 volts at the moment. Yeah, so that's 7 volts, and there's quite a lot of activity around here. It's bubbling away quite nicely. So I'm going to wind the voltage up. So that's 24 volts. It's about 2.2 amps, and yeah, it's getting quite active. You can see that quite clearly. So we'll leave that running. That's probably going to take some time, and we'll come back in. We'll give it 10 minutes, and then we'll come back in 10 minutes. Well, we've just passed 10 minutes, and I think you can see that the current has increased. It's now about 2.5 amps, and the solution is starting to turn green, which is what we would hope for. So let's have a close-up of the solution. Yeah, as you can see, it's definitely starting to turn green. We've got two distinct lots of bubbling. There's between the plates here, but there's also quite a bit of bubbling at the back of this plate as well. So yeah, and the solution is definitely warming up, which you'd expect because you've got, well, it's 2.5 amps of current flowing through that solution. So let's have a quick look from the top. I think you can see that the bubbling is quite energetic, which from my research apparently is, you know, that's what's supposed to happen, particularly if I mean, I've got the voltage up around 24 volts, and obviously when we go start the actual nickel plating process, we'll only be running at about 4.5 volts. But for creating the solution, this is the higher voltage definitely helps you to speed up the process. And also, of course, as the solution warms up, that will increase the speed at which it all works out, because generally heat encourages chemical reactions. So, okay, well, we're up to 12 minutes now, so we'll bring you back after 20 minutes. Yeah, bring it back after 20 minutes. Well, we're just coming up on 20 minutes, and the reaction is still very vigorous that's going on in there, which I would expect it to be. Let's have a look at the solution again. Yeah, the solution is very definitely turning green now. You can quite clearly see that, and as you see, there's still an awful lot of bubbling going on. So yeah, so I'm going to let that run. It's probably going to take a couple of hours to complete. Yes, the solution is definitely warming up now, which again you would expect. So okay, so we'll come back in a couple of hours. Okay, we're coming up on 2 hours. Let's have a quick close in on the timer. 120 minutes. We are at 2 hours. Okay, let's come back out again. Current's risen to about just under 4 amps. I've moved the plates apart because the current was rising quite rapidly. So we'll have a quick look. Before I turn it off, we'll have a quick look at from the top. There's still quite a bit of bubbling going on, but it's not quite as vicious as it was when we started. So I'm going to turn the power off now, and it stops almost immediately, which is what you'd expect. So that's been running for 2 hours. Now I think you can see the steam that's coming off of that. This is actually quite warm now, which is, you know, there's a lot of current flowing through that solution. Now the other reason for the steam is it's quite cold in my workshop because I've got the window open. The reason I have the window open is because Two of the byproducts from this process are oxygen, which is great, and hydrogen, which is not so great. So if you're going to do this, you really need to do it in a ventilated area. So that's why I've got the window open. Okay, so we now have our solution. So I think what we'll do is see if we can plate something. Before we do that, let's have a look at the actual plates. So that's the negative one, which I think let me close in on that a little bit. Quite badly eaten away at the bottom. And that's the positive one, which I think you can tell is, you know, pretty much untouched. I've removed one of the plates and I've dropped the voltage down to 4.5 volts, and our test piece will be this cartridge case. Now I've polished part of it, it's brass obviously. I polished part of it and I've left the other part tarnished, but I have wiped the whole thing over with acetone to clean it. We'll see how the plate works on the different surfaces of the brass case. Now it's important that you connect the negative lead from your power supply to whatever it is you want to plate. Okay, right, so let's try it. Now the solution is very hot because it's been, you know, it's had all that current flowing through it for quite a long time, and as you can see, I think that it's bubbling away quite nicely. Right, it's been in probably what, 30 seconds, something like that. So let's pull it out and have a look at it. Yes, already there's a nice coating of nickel on there already. So we'll stick it back in, do a little bit more. Apparently it does make quite a lot of difference, the temperature of the solution. If it's nice and hot, it will work a lot faster. Right. Well, there we go. Yeah, it looks pretty good. And it's all over it. It's done the end. Now, I don't know whether it's going to show up on camera, but the bottom half I polished. And from about there, that was just tarnished. And it's pretty clear to my eyes that the bottom half is much shinier. The nickel plate is much shinier. It's much duller on the top. You can see the bit there where I had the croc clip covering it up, and it's not plated. But yeah, I'd have to call this whole thing a success. So yeah, I'll bring you back in the future. I'll do another video when I actually come to plate something that I need to plate rather than a test piece like this cartridge case. But no, I think for now we'll have to call that whole thing a success.